Welcome back, everyone. So the next talks on the agenda are with regards to information extractors. We'll have Michael Johnson start us off with an overview of Clowder extractors and kind of fill in a little bit more of the details that we have kind of hinted at over the past day or so. First up is Michael Johnson, research software engineer at NCSA, with an introduction on Clowder information extractors.
Hello, I'm Michael Johnson. I'm a data engineer at NCSA, and today I'll be discussing about extractors. So in this talk, I'll give an overview about what extractors are. I'll give you some example extractors to look at. We'll talk about the types of extractors that exist. And then from there, we'll move on to discuss how we can manually submit extractors, as well as how we can configure extractors using parameters, how we can filter and search for extractors using the catalog, as well as how to monitor your extractor. So an extractor is essentially just a separate processing module that interacts with data within Clowder. It can be run anywhere as long as it can communicate with the same message bus that Clowder uses. Typically, extractors will download a file from Clowder, perform some function, some code, and then upload outputs such as new metadata or derive files back to Clowder. And so extractors can do more than just extract metadata, which was where the name came from. As we've seen, they can convert files between different file types. It can create derived files and re-upload those to Clowder. You can even download a file and read the file and push data to a different data source. And so we'll see later on that extractor types will be really useful in how we can organize and filter on extractors by function. So this flexibility on use is a powerful feature of extractors within the Clowder ecosystem. But another really powerful feature of extractors is that you can automate their running. And so here's just a brief example where we've enabled the automatic running of an image extractor. And so we've uploaded this image file, and automatically the extractor runs, and we get uploaded all this metadata associated with the image. So in this case, we have metadata about the image itself, about the file name, and as well as about the extractor. So here's just a brief overview of the Clowder ecosystem. As you can see at the top, we have multiple instances of Clowder speaking to the extraction bus. And down below, we have the various extractors that are also communicating to the same extraction bus. I think it's important to note that multiple instances of Clowder talk to the same bus, so you don't have to basically create multiple instances of your extractors across multiple instances of Clowder, which is quite useful. However, if you expect to do a lot of work, a lot of processing with a particular extractor, you can create multiple instances of that extractor, as we see in the file digest and EXIF examples, where basically if you upload multiple instances of the extractor, you can just help distribute that load over many operations. I think also you can see the word count example that these extractors can also speak to the web API, and so that can be useful as well. Here's just an example of the message payload that gets sent to RabbitMQ. This has basically data regarding the file type, the file ID and the dataset ID that the file came from, and as well as sort of the action or event that is occurring on the particular file. So in this sense, down below on the routing key, you can see that a file is being removed from the dataset. Here's just a brief overview of all the extractor events. We'll see there's file adding and removing from a data set, there's metadata adding and removing from a data set, manual submission, etc. So for some core extractors, so there's been a lot of development of extractors, and there's many that exist out there. I just want to briefly touch on a couple of them that could be useful. So the core extractors are a handy set that are extractors that are developed and maintained by NCSA. You can find them on the Clowder Framework GitHub page. These extractors include audio previews, image file digests, which basically give you a checksum of the image of a file, and then you have image previews, video previews, PDF and Office previews, which give you thumbnails and lower resolution images. So these features are, as extractors, are allow for easy scalability when your Clowder instances scale to high volumes. We also have geospatial extractors, also found on the Clowder framework. That's useful for extracting geospatial data. So we have some GeoTIFF metadata and preview extractors, as well as a GeoShape preview. And we also have a PyCSW extractor, which retrieves CSW metadata. It's important to note that I think both previews, the GeoTIFF and GeoShape preview, do require a GeoServer to be up and running, but those can be quite useful. And so as we've seen, extractors are doing more than just metadata extractions. And so extractor types allow us to distinguish between different categories of extractors. This is a relatively new feature that's not fully utilized yet, but the overall goal is to organize extractors by purpose. So we can separate out metadata extractors from archiving extractors from other extractors. Here's just a brief overview of the current extractor types. Extract is sort of the traditional extractor that's adding metadata or derived outputs to Clowder. There's also convert. I think what's an interesting one is archive and publish, which allow you to sort of mark an extractor that's pushing data to an external repository, for instance, which can be useful. So there's two ways you can start an extractor. One is automatic, where there's no user action required, and the other one's manual. So for the automatic, it's based on MIME type, and it needs to be enabled by an administrator of the space or Clowder. And manually, user can start the extractor with any optional parameters and can be done from the command line as well. So to enable an extractor, you go to, as an admin, you go to your space and click on extractors, and you'll see a list that looks like this. And you can see on the right-hand side is where you can sort of enable in space or disable your extractors for automatic running. And by default, extractors are not automated. So to manually submit a file, you go to your data set, click on a file, and you click submit for extraction, and you'll get a list that looks like this, basically, which is all the extractors that are available for you to submit with. And then you just click submit, and the file will be submitted with that particular extractor. You can also do the same with the data set. So for instance, if you have a whole data set of similar image or file types, and you want to run it on all those, you can basically run it at the data set level. A couple things I want to point out is you've seen a couple of those extractors in that list had parameters. And so the submission parameters are a great way to configure your extractors for multiple processing modes. And that gives the user a lot of flexibility and use in how you run your extractor. You can default your parameters, which allow for easy automation, but then you can also have different modes for manual submission as well. So here's an example where the NCSA archive extractor has an archive and unarchive operation. And then the NCSA open drone map extractor here has an image quality, one that you can toggle. And then here's just a brief example of how you would manually submit through the API. So here's just a simple curl post, a curl command that is running the NCSA word count extractor. And you can get full API documentation under the help menu of your Clowder instance, and that'll give you basically a whole run of various options for your API, and also an ability to test those APIs calls as well. So once you submit an extractor, you can look at the extraction events via the Clowder interface. So you click on the data set or the file, and you can click on extractions, and you'll see a whole list of events that occurred with that file. And so in this sense, this gives you a handy log of when various extractors were submitted and any log messages that might be pertinent, whether it was successful or failed, etc. You can find them here. Now, if you want to search for your extractors, you can find that in the extractor catalog. And here is you go to Explore and then click on Extractors. You'll get a list of extractors as well as a filter menu, which you can filter on extractor name, contributors. You can search on extractors based on what metadata they produce, as well as what triggers they run on, which is all very useful. And so here's just an example of that list that you'll get from that. You'll see name, authors, and other information. I just want to make a brief note that I think I think it's really important that we have authors here. As one, we at Clowder want to give credit where credit's due. So if you actually develop an extractor, we think it's important that you get credit for that, and that's shown here via the metadata of each extractor with the contributors. It's also a good way too, if you develop an extractor on your team and someone's having issues, then there's someone that they can point to and discuss about what issues they may be having. So if you click on an extractor in that list, you'll see a page like this, which gives you more details on the extractor. So basic information, a description, author, as well as any of the repos it's associated with, contributors, as well as the file triggers. And all this information you see here, basically the metadata about the extractor, is configured using the extractor manifest, and what we call the extractor info.json file, which is just a simple JSON file with the following information. I do want to point out a couple things down below. There's the process field, which in this case is how you can configure the triggers for the extractor. And so in this sense, in this case, this extractor is going to run when a file is added to the data set. This is also where you would, in this file, you would also configure your parameters as well. You can also monitor extractors, the extractor monitor, which can be deployed alongside your Clowder instance, and it gives an overview, global view of your registered extractors and their use within Clowder. So in this example, here's what you would see. You can see your list of extractors that have been registered to Clowder, the versions. Consumers is essentially the number of instances of that extractor that are running. So if you had 3 of the same extractor, 3 instances of the extractor, you would see 3 under the consumer column. Here you can also see errors, which it could be useful to see if a message gets submitted that can't be processed by Clowder, it'll show up here. And so if there's any kind of global problems with an extractor, this is kind of be a handy way to kind of find that out. Lastly, if you want to develop extractors, you can do so in Python and in Java. Both have GitHub repos on our Clowder framework GitHub at the following links. You can also develop extractors from scratch using RabbitMQ libraries, as well as HTTP and JSON. And I wanted to point out that the next talk, how to create a new extractor session, will kind of go into more detail about these extractors and how you can actually create them yourselves. So thank you. If there's any questions, I'll be online on the Slack channel. And thanks again.
Thank you, Michael. So that was a lot of information in a fairly short presentation. So if you have any questions for Michael, please, you can unmute yourself, raise your hand, or just type it in the chat.
So I had a question about taking a Python script, so something that we may have on in a notebook, for example, a contributor notebook, and then turning it into an extractor. Is there an easy way to do that, to integrate what is essentially existing Python scripts?
That's a good question. I actually don't know about Jupyter notebooks. Maybe I don't have a whole lot of experience with those. But we do have this concept within PyClowder of a simple extractor where it basically, if you have a piece of Python code that does some operation, and if you basically return a dictionary of metadata or some other thing, using the simple extractor, it basically helps you interface with Clowder, so that way you can just hook your Python code to Clowder without actually doing a lot of the Clowder actions. And so that's basically really trying to bridge that gap of like, you have code, can we just get you to kind of hook it up to Clowder and run it? And so there is some examples of simple extractors on the PyClowder GitHub page, but I think we're also looking into revamping that simple extractor to make it even easier for developers who have an existing code to just hook it up to an extractor.
I had a quick one. I was wondering that, say, while an extractor is running and then somehow it fails, so can it maybe restart? Does it store its state, maybe the list of arguments, so that one can run later?
I know that I think within Clowder itself, there's sort of a default restart of like 10 tries or something. So there is, it does attempt retries on fails. As far as saving state, I may have to defer to either Rob or Luigi on that. I'm not entirely sure. if it has any sort of intermediate state saved.
Yeah, so I'll answer that question. So this is specifically in PyClowder. What we have there is the ability for PyClowder itself to know that a extraction failed, and it will retry 10 times. What it will do is it will take the message that was sent to RabbitMQ and requeue it. So you have the exact same message again that you can retry. After 10 times, what PyClowder will do is it will take the message and move it to an error queue. So if you look at the RabbitMQ interface, you will see error dot and then the queue name. And so you could go back there and find the existing message and relook at the message. We use this for debugging extractors. So that way, if an extractor has failed and you finally find out what the exact error is and you fix it, you can take all the messages and reprocess them by just pushing them back into the original extractor queue, and they will get picked up by the new version of the extractor.
Thank you so much.
Another question about previews of proprietary formats, example, microscope formats. Is this possible? So this is regarding previewers, and yes, it is possible. There's different ways to do that. So you could use extractors to create intermediate representations, or you can directly just have access to the raw bytes if you know how to do that in JavaScript, if you have a library that deals with that specific file format. But extractors would help to go from that to some other representation. Michael, is there anything you would like to add to that?
I think you covered it well.
I was going to say, I put a little comment in the chat that for another project, we've used HyperSpy, which is a Python module that did handle digital micrograph and a few other formats. I don't remember what the other ones were, but I know that it's been used for a couple of brands of microscopes, but I just don't remember what any of the other ones are.
Thank you, Todd. All right, so thank you, Michael, for your presentation.